All right, Unit 3, Similarity, Lesson 7, Similar Triangles. Our objective, students will identify and use theorems to determine or prove two triangles are similar. So we have congruent and similar triangles. Congruent is basically the triangles are equal to one another. Think of like twins, brother and brother, they're twins, so they're the same. Similar figures is the sides are proportional and the angles are equal. So that would be something like a younger brother, older brother. So very similar, but not exactly the same. And the biggest thing is sides are different. Angles will always be the same in both congruent and similar, but sides will be different. So triangle congruence, or equal triangles. You can prove two triangles are congruent if they have all the exact same side lengths. So side, side, side. So you can see this side GH is similar or equal in length to PQ. HF is equal in length to QR. And GF is equal in length to PR. So that means these two triangles are congruent. Another way we can do that is if we have side, angle, side. Now the angle must be between the two sides. You can't have, like, let's say angle B and F were the same measure. That would not mean that these two triangles are the same. It's not any two sides at any angle. It has to be a side and a side with an angle in between it. So we can see of a side here, BC is equal to FD, and C and D are equal, and then measure CA and DE are equal. So that means that these two triangles are also congruent. What we're going to talk about in a second, I'm going to jump forward, is when we have corresponding parts of congruent triangles are congruent. So this is a CPCTC. Basically what they're saying is if we can prove two triangles are congruent, we know all the other lengths and all the other angles in that triangle are also equal. So going back up here, if we know that these two triangles are equal, we know the angles of all these, like G and P are equal, H and Q are equal, F and R are equal. Same thing down here. If we can prove that these two triangles are congruent, we know everything else is also equal to one another. BA is equal to FE, angle B and angle F are equal, and angle A and angle E are equal. So two more. We have angle, angle, side. So that's two angles in a row, which that'll actually always be the case. You can't have not two angles in a row in a triangle. But angle, angle, and side. So that means that if this angle, as long as you have two angles and one side are congruent, you basically have a congruent triangle. Because if we move this line, let's say it was between DC, well now we're just using angle, side, angle theorem. Okay, or if we moved over to CM, it's still angle, angle, side, just angle from here, angle, and then side. So if you have two angles and a side that are congruent or equal to one another, those two triangles are going to be congruent no matter what. Now it's just which order do they come in, if it's angle, angle, side, or if it's angle, side, angle. And that's just where the side goes. We talked about this, so once again, we know that if these two triangles are congruent, so is everything else in that triangle. Model A. Is there enough information to prove that the two triangles are congruent? If so, write the congruent statement and the name of the theorem. If not, write not possible and tell what other information you need. So, we have these two triangles, ANG and RWT. Well, we have two sides, A and N, R and W are equal. NG, WT are equal. And we have an angle in between them. So what we have is side, angle, side. Side, angle, side postulate. So because of the side, angle, side postulate, these two triangles are congruent. So our congruent statement, we would have a triangle. I don't have a way to write triangle on my computer. Just realizing that. I like the shape.